This video is going to be on basic trigonomic ratios. We're going to start with some review of right triangles, and then we're going to go straight into the ratios. Alright, so right triangles. There's only a few things you really need to know for this video, which is going to be that the hypotenuse is this side. It's the longest side. These other two sides are called legs, and a right triangle is denoted by this little corner right here that signifies a 90-degree angle. Alright? So, SOHCAHTOA. This is one of the most important mnemonics just in general, okay? It's super useful. It can help us remember all of these ratios. So first I'm going to go over the ratios, and then I'm going to show you how SOHCAHTOA can be used to remember them. So, sine is equal to opposite over hypotenuse. So let's say we have an angle theta, right? And theta usually denotes angles, so you're going to want to get used to using theta as an angle. So we know the hypotenuse is c, because it's the longest side. And then what we can do is if we draw a line from theta, and we draw it straight until it touches another line, another leg, we'll get that it touches A. So now A is the opposite, because it's opposite of the angle, right? So sine of theta is equal to A over C. Now, cosine is the adjacent over the hypotenuse. The hypotenuse is still the same, right? But the adjacent is the side that is adjacent to the angle, which is B, right? So we have cosine of theta is equal to B over C. And then I'm going to go down here so I have more space. Actually, no, I'll stay up here. You know what? We got tangent of theta. Well, what is tangent equal to? Tangent is equal to opposite over adjacent. We know that the opposite is A, and we know that the adjacent is B. So tangent of theta is A over B. Alright, so how can we use SOHCAHTOA to make memorizing all of these much easier? Well, SO stands for sine is equal to opposite over hypotenuse. Ka is cosine is equal to adjacent over hypotenuse. Toa is tangent is equal to opposite over adjacent. And it's a better way of memorizing it, I think. This is how I remember it, and it saves a lot of time memorizing. So I recommend that if you're going to remember anything from here, this is the best thing to remember. Alright, so let's do some examples. We're actually not going to do this one. Not just yet, at least maybe in another video. But for right now, we're just going to do this problem right here. And so we have an angle theta. And pause it right now. I want you to try and find the sine, cosine, and tangent of theta. So I assume that you've tried it. And so now I'm going to continue, and I'm going to show you how you should do it. So let's start with sine. Sine of theta is equal to opposite over hypotenuse. And we can see the hypotenuse is equal to 13, since 13 is the largest side on this triangle. And then the opposite, we can do the same thing we did earlier. We're going to draw a line, and we're just going to draw it straight until it touches one of the legs. And as you can see, it touches 5, so 5 is the opposite. So this is equal to 5, the opposite, over 13, the hypotenuse. So sine of theta is equal to 5 over 13. Okay, now we've got cosine of theta. Cosine of theta is equal to adjacent over hypotenuse, which is equal to, well, the adjacent side is the side that is touching theta. So we've got the hypotenuse, which can't be the adjacent, and then we've got this 12, which is also touching it. So since 12 is touching it, it must be the adjacent. So we've got 12 over, the hypotenuse doesn't change, it's still 13, so we've got 12 over 13. Alright, now we've got tangent of theta. So tangent of theta is equal to opposite over adjacent. And once again, if you ever forget any of these ratios, especially tangent, I find is harder to memorize than the others for some reason, you can always just remember SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we already know that the opposite is 5 when we did this line thing over here. So you got 5 over, and then we know the adjacent is 12, so it's 5 over 12. And those are the ratios. One quick thing to note is that the trig ratios will actually only work on right triangles, so if you have an equilateral triangle, you'll have to use different methods that we might explain in later videos. Also, you can't use the 90-degree angle as your theta, because you would have your hypotenuse as your opposite angle, which doesn't make sense. So